Uh, Good morning to all of you, and hello everyone. I heartily welcome all of you to today's second session. And now I'd like to introduce today's session speaker, Mr. Chaitra Nagraj. Madam is currently working in Department of Electronics and Communication Engineering, B&M Institute of Technology,
Okay.
and Madam has a 15 years of experience in teaching and industry altogether. To give you a brief glimpse of her academics, Madam has completed her BE from BMS College of Engineering and Masters from RV College of Engineering, Bangalore. In academics, she has excelled in both undergraduate and post-graduation studies, and Madam has received gold medal from Visvesvaraya Technological University for securing first rank in MTech. Currently, Madam is pursuing a PhD under VTU in the area of image processing, machine learning, and pattern classification, and her PhD thesis is accepted and she is waiting for defense, which would probably happen in next 10 days. And she has visited even abroad and a very famous Auburn University. She has collaborated and she is a part of research over there on brain images. In 2017, Madam has spent some time in USA for carrying out collaborative research work on brain images. Madam has also worked in Infosys Technologies as a software engineer before joining BNMIT. Madam has over 18 publications in a very reputed international journals and conferences. To mention to her credit, she has filed 2 Indian patents and one of them is published right now. Moreover, Madam has received a Best Faculty Award from Cognizant Technologies for the year 14-15. I'd like to welcome Madam to the today's session, and we are extremely privileged to have you, ma'am, because you have worked so much on machine learning, and your insights to this will be very helpful for us and for our teachers to implement in their projects and to to convey the same thing to the students too. And thank you very much, madam, for participating in this session. And I just hand it over to you now.
Thank you so much, sir, Hemant sir. And so before I proceed, I would like to thank the management of B&M Institute of Technology and the Department of Mechanical Engineering, Dr. Anil Kumar sir, the HOD, and all the organizing committee members for inviting me for this occasion. And it's a privilege. Although I'm not from a mechanical background, you deemed it fit that I will be able to, share a few of my experiences, and it could be helpful for all of you. Thank you so much, Hemant sir, and thanks for the complete organizing committee. Thank you, Raghavendra sir, and all of you. I guess, can I start with the presentation, sir?
Yes, ma'am, you can.
Okay. Yes. Before I actually proceed with the presentation, one of the reasons what motivated me to agree for this particular faculty development program was that it's been so that from some few months or say maybe a year or so, I've been associated with few of the mechanical engineering students and mechanical engineers to just come up with certain projects. It so happened that a couple of months back, maybe it was just 3 months back, there was a doctor from Nimans, Bangalore. So who approached me. Basically, he's a psychologist and he's a psychiatrist. They approached me to come up with a certain devices for the infants. So what they were finding was that Nimans every year, I would like to put it on record, Nimans every year, there will be certain cases, say that the parents of very small babies and the infants, around maybe around the cases are around maybe 6,000 to 7,000 cases where they approach or they consult doctors in Nimans because they find that their infants are not progressing the way they are supposed to progress when it comes to their motor skills, as in when the infant has to start sitting, when it has to start crawling, when it has to start walking, that is not happening in the stipulated duration where it is supposed to happen. So the Nimans doctors, they are actually finding a lot of parents approaching them for the consultation and aid, and that is where since all those doctors and many of those physiotherapists are overwhelmed with the kind of a demand, and where they can't go to every house, and where they try to help the infants or people there to just make sure that the infants have a natural growth record. But that is where they approached people who are working in the machine learning. I was fortunate to one of my collaborators. I was approached to carry out a project. Where we will be able to come up with certain devices. We will be able to come up with certain devices which will help the infants have a normal growth. So that is what the overall picture of the project was. But it so happened, yes, I have been working in the area of machine learning and pattern recognition. I will be able to see the infant and track the record and predict when it will start walking, when it will start standing, sitting. But I was not somebody who was an expert with something with the robotics. So that is where I had to collaborate. That is where I had to go out, reach out to people in mechanical engineering department, where we had to come up with certain devices where we would be able to help the infants. See, there is an intelligence part to that particular system. So especially when things like the pandemic, current pandemic where we have, imagine all those people who are in the need of physiotherapy. So we can't ask somebody else to visit our house, nor can we go and visit them. So there was a lot of difficulties that people were facing. So this is where the complete artificial intelligence became more relevant, because from the distance, it's something like a virtual physiotherapy that we were trying to develop, wherein we will be able to help the kid, will be able to come up with certain devices. Okay, we'll be able to come up with certain devices which has certain intelligence, so that those devices will be able to have or aid the parents and also the infant, so that it will have a normal progression wherein we will be able to see the infant at the right stages sit, stand up or walk. This is just one motivation that I'm just quoting. About this again I'll be talking when I'm just sharing the slides as well. So what I'm trying to tell here is, we have gone are the days where I used to work in an isolation calling myself an electronics engineer, and I'm a computer science engineer. But every department, everything needs to go in hand, because we are trying to come up with certain most intelligent systems. We are heading towards the most intelligent systems, where we are trying to build systems where it involves robotics, it involves computer vision, it involves deep learning. All of them put together is how we can create this system. So the project that I had to agree with the demands, I had to work with mechanical engineers and myself and a group of students together. We have just started working on it. Of course, there's a lot of progress to be made, but that is where I realized the importance of our collaborations, and that is where I realized that we understand, as engineers, we understand each other domain, so that we will be able to complement each other, work together, and come up with more sophisticated systems. So that's just a preamble about why I agreed for a mechanical engineering FDP, and where I think that everybody from most of the engineers from the mechanical engineering background as well, at least need to understand the basics of artificial intelligence and machine learning, so that we will be able to collaborate and bring up the most sophisticated systems. Thank you. So let me just share my slide set. I hope all of you are able to see the slides. Yes, the title, that is application of AI and deep learning. And Hemant sir has introduced me well, so I need not give a self-introduction about myself. So here today I would be talking more so about the applications of artificial intelligence and deep learning, rather than not going way too much technical into any of the specific areas or any of the specific applications. So let me just start off. So why this topic and what are the applications of AI? Just to tell you people, we know that artificial intelligence has become ubiquitous. That is, it is anywhere and everywhere. I cannot say that artificial intelligence has an application in this area, that area, or that area. As and when I sit here and I'm talking to you people, there's so much of intelligent systems, the way they are working around us. So the few of the examples or areas I put it on this particular slide just to make a collage of all the applications and things which day to day we people have been using, right? So I'm sure most of you would have already observed. Somehow we would be at home. Let's say I'm just talking about one of the movies, or one of the, let's say I'm trying to buy something. I'm trying to buy a particular gadget, a mobile phone. So I'm just discussing about that with the family and thinking about which brand is good or which brand is not good. Suddenly, when I just open my Facebook or the Instagram profile, I would see ads. I would see advertisements which are coming up unknowingly all about the mobile brand itself. How is that even happening? That somebody is listening to me, right? Somebody is knowing, and it's not a totally irrelevant ad that I'm getting, because today I'm talking about buying a mobile phone, and just in few hours I'm able to see the advertisements which is indicating which mobile phone is good and what I need to be working on. So that is something like, how the artificial intelligence is literally taking over the complete lifestyle, or how it's moving. So the few of the examples that I put just to start off with, to introduce or motivate you people towards the coming presentation. First and foremost, it's the self-driving cars. That is something, one of the most fascinating things, I'm sure, for most of us. I don't know how well it would fare if at all we introduce that in a country like India. But the self-driving car is something, you just leave it, and on its own, it's something like an autonomous car which goes on its own. It takes a turn. You just need to tell it from where to where you need to go, and it manages everything. So that a self-driving car is not something a distant future. It's already started picking up, and as and when we are talking here, there's a lot of advancements that's going on. There's one more example that's given, that is for the face recognition. I'm sure most of the colleges now, we have a biometric system. As and when in the morning, the first thing I do when I come to the college is stand in front of the biometric system and ask it to recognize my face. Right? It is becoming much more better and more accurate with the current new algorithms that people are using, and the face recognition or the iris recognition, fingertips, or any of the kind of the recognition systems are one of the most advanced systems that we have today. One more thing, yes, that is nothing but our healthcare. That is something which is taken over the precedence over every other area, especially when we talk about the research in AI. Healthcare is something, especially with the current pandemic and the way things, the whole world is heading towards. Healthcare is one of the most important areas where a lot of research is happening. Even my PhD work was based on the research on the brain images itself, where I took a set of brain images and I was trying to classify it belongs to which particular category. So that was also in the healthcare domain, and we are trying to come up with, let's say, the remote something, let's say we are trying to diagnose or trying to predict many more years prior, even much before even it comes to, so that they will be given the right treatment, or they will be given the right aid. So that is the lot of different verticals we can look at when we talk about the healthcare. Another thing that I've put up is your virtual personal assistant. Today I can sit in one place and I can say, Siri, please call home, and I can say, Alexa, why don't you switch on the fan, or Alexa, set a reminder. So all these kind of virtual assistants, just sitting in one place, I will be able to control everything in the home. Even why in one place. Right now, the scenario is so that, let's say I'm traveling, I'm in a different country, and I just want to make sure that my home is safe. Using your mobile phone, I will be able to have a look and peek into the complete house, and I can just control the whole app using my voice. And, it is, of course, it works with the IoT and as well as the AI. There's a combination of two things there, and that is where I can make sure that my house is safe. And I put one more, that is the Google. Basically, whenever we just open the Gmail every morning, the first thing that we do with any of the mail servers, the Gmail or the Yahoo which we open, it is able to segregate what is a junk mail, what is not. There are mails which are relevant to me are under my inbox. All those things which are irrelevant, which is from a spam, it is just directly taken to the junk or the spam. Every mail browser that we are using today is able to do that. How come it is doing? That is also a machine learning algorithm that is working behind the Gmail to classify which particular mail is something relevant to me, which particular mail is a junk mail or the spam mail. That's where I put in Google. And also when we just try to search the Google, all those things which are relevant and most important or most visited sites are what comes up, right? And also the ads and everything. All these things, there's a lot of machine learning that is working behind the day-to-day, the mail servers and the search engines that we are using. And I put one more here, that is the Alphago. Alphago is one of the first, gaming softwares to play a game called Go, which was one of the most complex. This was one of the first, softwares which could beat a human intelligence. So the Go is actually a game where it involves a lot of intelligence and a lot of complex analysis. But there were a lot of, rather other conventional programs which were making this particular game work. But it so happened as and when it is progressed, the machine learning algorithms were introduced. And today the Alphago, what we have, can beat the humans. I'm just quoting Alphago. And of course we have chess masters to beat a human in a game of chess, and lot of things which involves lot of intelligence, and people are able to work on it. So that's one of the examples I've given, just to people are so much fascinated by the gaming. I just wanted to tell you there is a lot of machine learning algorithms behind this gaming. This is just an introduction slides. I would be taking a couple of specific examples to explain, and also I would be talking about few projects that I'm working on. So my outline of the complete presentation would be the introduction to AI, ML, and of course the deep learning, and some basics. I think there are few basics that we need to know before even we try to understand the applications of AI, ML, and deep learning. So there is some basics I touch upon. I am sure that few of them you would have already known, few of them you might not know. But just for the completion, I thought, let me just go through the few basics to understand things better. And the steps in machine learning, what are the steps involved when, if at all, you're trying to build a machine learning algorithm? And why deep learning? What is the importance? What is deep learning is what I'm just going to be discussing. Most of the time I would be just dedicating to the application of AI, and of course I wouldn't be talking about everything, but only around 2-3 small projects which currently I am working on, which involves machine learning and also which involves mechanical engineers. So before we proceed, what is intelligence? When do you say, what is intelligence for me? If at all we say that we have intelligent systems, we have people who are intelligent, we are talking about intelligence. What is intelligence? When do we say, what is it that we are trying to realize? Yes, I'm trying to create artificial intelligence. But don't you think, what are the kind of systems we call intelligence? Is when we say a human being is intelligent, I don't mean he's able to solve the complex mathematical problems. When I say it is intelligence, there are basic things that human is able to accomplish, and that is why we call him as intelligent. So what are those? Basically, first and foremost, it's the generalized learning. We learn. Learning is not just about reading the textbook and learning something, not about attending a webinar and knowing something. When I say learning, just a human being, an infant was born, it starts learning. First thing it learns who is its mother. It could be through the smell, or it could be through watching the same person over and over. It could be through the touch of the person, but it learned. It learned who is the mother. It learned who are the well-wishers. Even after a few months, if at all somebody else takes the baby, it knows this is not a familiar person. How did it know? There is a learning. So that, and also it starts learning the languages. It starts learning 2-letter words. It starts speaking 2-letter words. All this is the generalized learning, and it starts speaking, it starts standing, it starts walking, right? learning is not necessarily from the textbook or the books or anything. Even, of course, even that's learning. But when I say generalized learning, just from our experience, just from looking at something, just listening to something, just touching something, we have learned something, right? That's the generalized learning, and that is because we have brains and we have intelligence. The next thing would be reasoning. As human beings, we can reason out. See, one thing is, we take all these things for granted. We just assume, we know all these things, but we wouldn't have even given a thought just to realize the same thing in a system, in, say, as a computer program, or through recreate using a robot, how difficult it is. So that would be your reasoning. Then, that is, we try to reason out things. We try to reason, if at all something failed, why did it fail? If at all, I couldn't get through a certain exam, why didn't I get through it? If at all, I just go straight and I reason out, how do I need to go so that I reach that particular destination? So the reasoning is something, one of the attributes that tells that we are intelligent. Then solving a problem. The name itself says we solve day to day each and every problem. Okay, this was a network issue. How do I resolve it? And if at all, problem solving need not be on the book and the paper. Every day I need to walk from here to there. If at all, let's say I just stumble or just fall, how do I stand back? That's also, there's a problem and I solve it. If there is a wound, how do I, what I need to do next? So that's problem solving. And the perception. I have a perception and I have something about each and every thing that is happening around. That's perception. And the most important quality that we have, and it's actually supposed to be most complex, and we people just take it for granted. Imagine how sophisticated our human brain is. That thing is nothing but your understanding language. If at all I'm speaking and you're able to understand, believe me, there's a lot of things that's happening in your brain. From your auditory system, where it goes to your brain, the region, and it, understands and it converts and it stores. There's understanding language is one of the most important things, and it's considered to be one of the most difficult things. There are a lot of countries where, in India, we are not thinking much on these, but a lot of countries where they specifically tell parents that for an infant, don't teach more than one language till he is 2-year-old or 3-year-old. But we try to use, we have a language, let's say Tamil, Telugu at home, let's say outside it is Kannada we are speaking, and he goes to a kindergarten, there he has to speak English. Already would have introduced a kid to 3 different languages. Believe me, there's a lot of complex things that's involved in understanding the language. We just take it for granted, but there are countries where they insist a kid should just learn one language for a certain duration of time and at a time. So one thing. So all these things contributes to intelligence. So if at all I'm trying to create an artificially intelligent system, if at all I'm trying to create an intelligent system, then these are the things that I'm trying to put in that particular system. That is, I'm trying to make it learn, reason, solve a particular problem, have a perception, or understand language. And the few systems can have 1 or 2 of them, or it can have all of them. I would be talking about the levels of AI in the next few slides. So that's intelligence for you. There's one huge big question mark at the, people are always confused or always not aware about, they use these terms interchangeably. That is artificial intelligence, machine learning, and deep learning. So what's the difference between these 3? What is artificial intelligence? What is machine learning? And what is deep learning? Artificial intelligence is something where we are trying to create the intelligence artificially. So it can be, it's a big ocean of all the machine learning, deep learning, everything put together. As you can see on the slide, it's all comprising, and that's artificial intelligence for you. And we can realize artificial intelligence through a set of computer programs which can learn on its own, and that's machine learning. Okay, artificial intelligence can be realized using machine learning algorithms. And one of the machine learning algorithms and one of the ways of doing the machine learning or coming up with an artificial system is your deep learning. So people think artificial intelligence is deep learning. Not necessary. Deep learning is just a part of artificial intelligence, and deep learning is just a part of machine learning. It is not that, but the artificial intelligence or the machine learning is way beyond deep learning. It's not necessary that everywhere you would be using deep learning or the artificial neural networks. Okay, deep learning is nothing but the artificial neural networks with many more layers. So it is not just about deep learning or artificial neural networks. Artificial intelligence is way beyond and much more complex and much more than your deep learning and machine learning. So coming to the next part, that is the different levels of artificial intelligence. This is what I was just mentioning previously. There are 3 levels of AI. You can have applications in any of these levels. These are very much relevant for me to talk about your applications of AI. So only those basics I'm just considering here. All right, I repeat, these things that I'm discussing, the basics are very much relevant to understand the applications of AI or the machine learning. So that is why I'm just discussing these basics. But the basics of AI are, it's a big ocean. There are much more than what I would be talking about. So what are the different levels of AI? One is your artificial narrow intelligence, general intelligence, super intelligence. Narrow intelligence, general intelligence, super intelligence. What do you think we humans are? We humans are, actually, believe me, any individual is super intelligent. Any normal human being is super intelligence when we talk about trying to compare that with an artificially intelligent system that we are trying to realize. So when I say narrow intelligence, just talking about each one of them, when I say narrow intelligence, it means that I did speak about intelligence. When do you say a person is intelligent? So if at all, this narrow intelligence actually can, implement only one of them. It can do only one task. So let's say something like a face recognition system. It can actually recognize the face only, that is the only thing that it can do, right? The recognition of face. How it does? It takes the images, it already is trained to recognize. So if at all it matches with one of the things that is already stored, it maps and then it realizes, and that is how it works. That is your face recognition system is a narrow intelligent system because it can do only one task, that is the recognition of the face. That's narrow intelligence for you. All right. So the next thing is general intelligence. So when I say general intelligence, it can do more than one task. It could be 2 to 3 tasks put together, it will be able to do. So when we say general intelligence, let's say it is also able to recognize the face, at that take a decision. It is able to understand speech also. Let's say through voice also, you're telling something, you giving a password, it is still able to understand that, right? There are multiple things. It is not just your face recognition. It is also able to do recognize your speech and also the face. That becomes your 2 to 3 tasks. Let's say it can solve a certain problem. Your biometric wouldn't do that, right? Let's say it can solve a certain problem and give a solution. So 2 to 3 things together becomes your general intelligence. Then what is super intelligence? What is super intelligence? Super intelligence would be where you will be able to do all the intelligent things that a human being can do. So we are able to see, we are able to listen, we are able to understand, we are able to take all the senses, whatever the sensor information that I'm getting, I'm able to process. Somebody asks me a question, I understand, I give a reply. There's a problem given to me, I will be able to solve it. I can also walk, I can make a decision, I can reason out, I have a perception, everything together. Any normal human being can do. That's super intelligence, and that is what we plan or we want to achieve. Right now we are much behind that. So what we have achieved so far, when I say we mean that human beings have achieved so far. One is the narrow intelligence with a very small single application intelligence systems that we have already realized. And of course, the general intelligence system where set of things work together and we are able to do intelligent things, the general intelligence is achieved. And super intelligence is predicted. We people are thinking at least by 2050 we will be able to achieve. Okay, even I mean, even your autonomous car or the self-driving car can be something more than general intelligence, but it is still not a super intelligence. Super intelligence could be what you see in this fiction movies where you have a complete human being which has been created by your the systems, and his robotics and computer vision, everything in working, and it is able to do all the things that a human being can do. One example that I can take is the robo from your Rajnikant movie, or from the Avengers, the robot that was created. All these things are the super intelligence, which is still a fiction, and it is yet to be achieved. So at this point, I would give 1 minute break. Any question? Any question? So if you people have an access to the chat window, please, you can put it on the chat window. If you people have access to the chat window, if you have any question, you can put it on the chat window. I'm just giving a minute break. Any questions? Anybody has got questions, you can always put on the chat window. You can interrupt me and okay, let me continue. I hope the slides are visible. So I was just talking about the levels of AI. Going to the next one, there is something, this is the areas of AI, or I can also call it as elements of AI. There are a lot of areas where people call it as elements of AI. So coming to the elements of AI, what are the different ways, different areas where people can work on, or where it just finds its application. I wouldn't say applications, where how exactly we can realize the AI, whether it is the generalized or the super, or the narrow AI. So these are the different areas where you can realize the AI. So one could be your machine learning. I did speak about the difference between AI, machine learning, and the deep learning. So machine learning are the set of programs. Machine learning are the set of computer programs. The one difference between the normal programs and these machine learning programs would be that these programs can learn on their own. They can learn on their own. So with the experience, with more data, with more inputs, it keeps learning, and in future it keeps performing much better. So that's how the machine learning would be. It is not like any other sequential programming where you have a set of sequence or the commands and it executes one after another. So it is from the conventional programming to machine learning programs. The difference is that here the set of programs can learn on their own and they can proceed. And one of the ways of realizing machine learning would be your neural networks. Neural networks is something where we are trying to mimic the human brain itself. There are a lot of other machine learning algorithms where we are trying to realize it with a set of programs, but here we are trying to mimic the brain itself. So what we are trying to create is the intelligence, the artificial intelligence. So rather create it the way the human brain works. That's where the neural networks came into picture. The next thing would be natural language processing. So when we talk about the natural language processing here, Basically, this particular area, if at all you have your virtual assistant where you give a, say you just give a command, Alexa, do this or do that, if at all it is able to understand and comprehend, it is all because of the natural language processing that is working behind. Basically, it can convert the speech to text or text to speech, right? And it also takes all your text data or the speech data and understand it and segregate it and do certain actions. That's natural language processing for you. The next thing is your evolutionary computing. Basically, it does the set of global optimization, and it is based on how exactly the biological evolution worked. That is, it has a trial and error methods, and it also the way the survival of the fittest, right? So that is how the human evolution works. Similarly, the evolutionary computing, basically it is for the optimization purpose that people make use of it, and it is somehow based on your biological evolution system. Then we have computer vision. If at all you want to have a self-driving car, first and foremost, let's say you are a driver, you're sitting in the driving seat, and if at all, you first thing that you would do is just look at the road, look at the street, look at the things around you, right? So here we try to see, capture what it is there, and the brain processes and takes a decision whether I need to start my engine, accelerate, go further, take right turn, take left turn. If at all there's somebody trying to overtake, all these things are the decisions that you're making. Everything starts with you looking at something. So that's computer vision, where we are trying to make the computer, vision. That is, we try to make the computer look at something and understand what it sees. So that's the area of computer vision. Right now, if at all we are trying to build a very sophisticated, most advanced AI systems, the computer vision would be the starting point where we try to look at things, try to understand, take it to the next level. Then we have expert systems. Expert systems are basically the knowledge, and it has the expert knowledge and expert experience in a particular area. So it is basically based on a certain rules. So here, if at all this particular area, let's say you have a industry that you're running and you have a certain automation that has to be controlled, that has to be planned, and it has to be governed. There are some decisions that your system wants to make even in the absence of human beings. So in there, you would create an expert system for that particular application, let's say the industry itself. There you would trying to automate certain things. So that is what your expert systems are. Then the speech interpretation, that is, we are trying to interpret the speech. There is a certain overlap between speech interpretation and natural language processing, but the tools that is used and how exactly the whole methodology that happens behind the speech interpretation and the natural language processing is much different. That is what distinguishes, that is what segregates natural language processing from speech interpretation. Then we have the robotic automation. That I need not tell anything much. That is quite evident and obvious, I'm sure. If not anything, people would visualize artificial intelligence to be big robots which can do anything and everything. So here, robotic automation, that is something more relevant for mechanical engineers, is what we have. At one point, even though we are trying to segregate these things, there could be a neural network which is working in we have machine learning algorithm there. You might have, even in robotic automation, it starts with, say, the computer vision itself. So all these areas do overlap. And here you also could be trying to come up with an expert system, right? They're trying to create an expert system. So, or also you could be giving a speech command. Even to the robot that you're using, you could be giving the speech command and trying to control something. So all these things kind of overlap. It is not like way too exclusive, but you can definitely pick and select and work on things depending on your application and your requirement. So the next thing would be, again, it's I thought this would also give, this is also something which talks about the elements of AI, but here we were trying to create the different branches or different areas in artificial intelligence. This particular slide gives you a better picture about what are the different areas, things that you can pick up. Let's say you start out, you have a particular project, particular research area, particular application where you want to make it a bit intelligent, where you want it to rather predict something, classify something. Let's say there is some machinery that is there and you don't want a human being to just inspect it. You want a machine to inspect that particular your machine and also say what are the errors, where is what's going wrong, how exactly you can correct it. That can be done using artificial intelligence. So what all you need to pick up, what are the different areas? One thing is the machine learning itself. Artificial intelligence has one of the parts as machine learning, as I mentioned. This, please observe, can be either deep learning or predictive analytics. That is deep learning. When I said, that is nothing but your the artificial neural networks with the higher layers. That is considered to be the most powerful right now, which can actually consider to be the best possible machine learning algorithm that can work. And another thing could be the predictive analytics. This basically uses the statistics and modeling techniques to make the prediction. Predictive analytics uses the statistics and certain modeling techniques to make the prediction. For example, the stock market, weather prediction, weather forecasting. You would want to know what exactly would be the weather after a certain number of days in a certain area, certain region, right? Or you would want to know how the stock market, particular stock would be performing after a few months. So that's part of an intelligent system. That predictive analytics is one thing that can be put under using the machine learning that can be realized, and deep learning. And then we have the natural language processing, as I mentioned. Basically, it is trying to understand the speech or the text. It's not just only the speech, or just because we use the terms here. So it can be either the speech or the text. So there was one project that we were working on. Let us say, as and when you people, let's say I'm just talking to you people or something, I would rather just show a certain text to you on a camera. So that particular text has to be captured and that has to be converted to text. And later, if at all somebody asks the question on it, on those things that I just spoke about, you should be able to answer. Right? So the system, when I say you, it's the system must be able to answer. So that can be done using your natural language processing. There was one more project that I worked on, especially in this particular semester. So wherein there are video lectures and classes, everything is in online mode. Most of us are academicians and we are much, we know the difficulties in sitting online throughout. So as and when, let's say I'm just giving this particular webinar and it is going on, and the whole thing, definitely whatever I'm talking will be recorded, and here there would be a lot of redundancy. I would have just told one sentence, after some 10 minutes or 15 minutes I would have told the same sentence. There could be unnecessary words. Rather than storing everything in your computer or your system, what you can do is just take out the most important lines of words. So we call it as parsing, and we take those things and store it. Okay, that can be done. And where is it useful? We just worked on a project where AI powered notes assistant. AI powered notes assistant, where as and when a student is attending the class, all those things that is taught by the teacher, spoken by the teacher, the speech is converted to text. In the text, it can be going to pages. There's no point in storing everything or reading through everything. So it just takes the most important points or the factors from that particular text and saves only that. So that was a note assistant. And there could be certain keywords. Let's say I just use the keyword, say something like image recognition. So if at all the student wants to know that any other web links or IEEE papers which talks more about image recognition, then there is something like a web links that is given in the notes assistant itself. Clicking on that, he will be able to go to the Google, read through that material and come back. So that was a notes assistant that we created using natural language processing. And using natural language processing, as I told you, there's one more project that I'm currently working on where Anybody just shows a text to the camera, you take all the text, save it in the form of the words in your memory, and if at all the question is asked, somebody asks a question on pertaining to anything that was shown, then that person will be able to, the computer will be able to give out the answer. That is your natural language processing. Under that, it could be translation. Yes, Google Translate. You just, let's say there is something that arrived from China. It is in Chinese. You take the Google Translator. I'm sure many of you might have used. You just keep it on that Chinese text that you have. That gets converted to English and you will be able to read. That is translation. Classification and clustering, I'll talk about this in the future slides rather than talking now. That is, classifying is segregating into two different sets. Clustering is grouping the similar ones. Information extraction, that is something, whatever I just specified, whether the notes assistant or whatever the text, help aiding you with the text. So all those things would be extracting the information. That is, all these things are part of your natural language processing. Then the speech is one big complete area that people have been working. Speech to text, text to speech, speech recognition systems. So those are things. Expert systems, I just mentioned, they have the expert knowledge and experience in a given area. There are certain rules using which they work. So you would rather create an expert system for a given field or area or an application. So that's expert system. It's more generic terms, but there are certain algorithms and methodologies people use. Planning, scheduling, and optimization, that's something which can be taken care by artificial intelligence. Robotics, that's one major thing. That's a lot of research and work is going on. We have robotic surgery to small robots helping us with a day-to-day, life. So all these things comes under robotics. And although earlier the robots were something following the general sequential program that we had given, now we are trying to make the robots intelligent as well. Vision, computer vision I spoke. Image recognition, trying to recognize an image. And machine vision, that is the computer vision that I told. It just takes the pic, understands, recognizes, and goes further. So before we proceed, there are two kinds of learning, supervised and unsupervised. So whenever we have a labeled data set, what do you mean by labeled data set? So I give you a certain data set. People, one thing you should need to know when we are actually venturing into artificial intelligence and machine learning, data is oil. That's what people call us. It's a new oil. That is, the data is the most important thing. More and more data we have, better your complete algorithm would work. So there are two kinds. One is the supervised learning and the unsupervised learning. When we talk about the supervised learning, that is, here I have a labeled data set. So when I give you the data set, I would have told what is what. So let's say you people had a biometric system in your college or any of the places that you're working in, and you just, how did you train the model? You just you made the system take 2-3 photographs, right? When you were taking the 2-3 photographs, the person had keyed in, this is the person. So let's say they take a person's image and they coin with a person A, picture 1, person A, picture 2, person A, picture 3, then the person B, person C, right? And it knows which picture corresponds to whom. That is supervised learning. It is labeled data that I'm giving to train that particular system. So in future, that person, let's say person C, goes and stands. It takes the picture and it tries to classify. It tries to classify out of, say, 3 people, person A, B, C, which particular person was that, and it sees that there is a more match to person C, and that is why it is person C. Correct? So you're trying to train the model with a labeled data set, and what you're having is a classification problem. We are trying to classify who is who. That's supervised learning for you. Correct? When we come about unsupervised learning, I'm not giving you any, I'm just giving you random 100 photographs. I'm not even telling you who is who. So there is a certain kind of a clusters that it's not, see, depending on the application, either it would be supervised or unsupervised, it depends. The example that I'm taking might not be relevant for the face recognition for unsupervised. So there, you wouldn't be knowing the data, what is what, under those kind of circumstances, we would be doing unsupervised, depending on how exactly the vectors are distributed. It is in the form of clusters. As you can see here, it's either, it's grouped on certain regions itself or the areas itself. So that's how it becomes, two kinds of clusters, and that is where it could be either the cluster 1 or cluster 2. So randomly I would give one new data, and depending on which particular cluster it belongs, nearest to which particular centroid of a cluster or any of those methods, you would say it belongs to cluster 1 or cluster 2. That is how you classify using unsupervised learning. Supervised, unsupervised, this is the some terminology you will always come upon. Then there can be two kinds of problems, people, in your any of the applications of your AI or ML. The problems could be either about the classification or regression. Classification or regression. So what do you mean by classification? Here we are trying to classify two different things. That is, I'm trying to classify whether it belongs to class A or class B. As I told you, a person, there are different individuals, whether it is the data set is for A, B, C, or that is something like a classification, whether it's a car or a truck, whether it's a cat or a dog. So any of those things is a classification problem. So let's say I'm trying to build a system where I'm trying to classify human beings and animals, trying to segregate that. So in that case, I would have given a lot of data of humans, a lot of data of different animals. I would have trained my machine learning algorithm. It could be any of the machine learning algorithm, or it could be a deep learning algorithm, any of it. Once I've trained it, so here it knows if at all I give a random image, it could be of human or animal, it will be able to segregate whether it is a human or animal. That's a classification problem. So most of the time you would be coming across classification. Let's say there is a machinery that you are taking an image of, and from a distance you're trying to analyze what are the components or whatever, where are the screws or whatever it is in that particular machinery. Then using that particular image, it will be able to classify whether this is a screw, this is something else. So depending on that, that's a classification problem. Another problem would be your regression. Okay, so basically regression would be something like trying to come up with a relationship between the variables to find out the best fit line or equation. Here you're trying to come up, just to understand the relationship between the variables to find the best fit line or the regression equation that can be used for the prediction. Basically regression, I can use it interchangeably for prediction. I'm trying to predict something. I'm trying to predict, if at all, looking at a certain cells or certain blood cells or something, whether this particular person is going to get diabetes or not after a few years. So that's a prediction. I'm going to predict this particular share is going to take this particular value. The weather is going to be raining after so many days. That's a prediction. So prediction can be, we collect a lot of data sets. Let's say people growing up in this particular area. Let's say we say in the Japan, they try to, they live for longer than, many of them longer than 100 years. That's a prediction. So how did we do? We just learned looking at a lot of people living in Japan. They have lived for so many years. So that's something like a learning that has happened. Based on that, we say that, that's a prediction that happens. Coming to what are the steps, if at all you're building a machine learning algorithm. First and foremost, as I mentioned, data is oil. So gathering the data. Now there are a lot of portals, a lot of places where you can easily get the data. And especially in US and Europe, they have come up with certain rules or certain, places where people have been told that then you should be sharing the data. So that is where, a lot of data is available online. There are a lot of forums, Kaggle and many other places where you can actually take the data. First step would be gathering the data. Next, preparing the data. That is nothing but your pre-processing. If at all it involves an image processing kind of an application. So what you would be doing, it could be cropping of the image so all the images are of the same size, or it could be denoising, blurring, making it bright. All those things are nothing but preparing the data. So there could be certain data sets of certain individuals you would have collected. There could be outliers. That is something, far away it is not necessary. You can remove them. You look at the noises and unnecessary things. All those cleaning up the data, everything comes under you're preparing the data, which is nothing but something like pre-processing. choosing the model. There's so many machine learning algorithms. Which one is the best fit for you? I cannot say for that particular application deep learning is working. Let me take deep learning. That is the best. But you need to know it is so much time consuming. It is so complex. Is it necessary for a very simple application to have deep learning? Is it necessary to have a sophisticated system to have deep learning? Really, that is not necessary, let's say. So then you could rather go for a more simple algorithm. You could go for decision tree or random forest. So that's choosing the model becomes very important. Then training. Let's say I decided on for a particular application, this model works better. Then I would need to train. Using the program, you feed the data, whatever the pre-processed data for the algorithm, you train it. You always make a 70-30, 60-40 training and testing data. You train the data with the remaining data, you test it to know how accurate it is. That is your evaluation. So as and when I train, then I do evaluation, that is testing of the data. Before I take a random other sample, I would rather test it. So I would have taken, let's say I give you 100 images, 60 images you have taken and trained the model. The remaining 40 you use it for testing to know how well it is working. So that there is no overfitting. Overfitting is it would have performed given 100% for the 60 images, but I give some other sample, it is not working at all. So that kind of a scenario should not happen. So evaluation becomes very important. Then the hyperparameter tuning. So these hyperparameters are, those whose values is used to control the complete learning process. It could be either model parameters or algorithm parameters. So hyperparameter is some terminology you will be coming across, especially when you're learning, when you are executing machine learning algorithms. Let's say in deep learning also. So you need to set, let's say you're using Python TensorFlow or something to implement something, you need to set certain hyperparameters. So these are the things, which we use to control the complete learning process. So hyperparameters are considered to be important. It could be just a mod parameter which cannot change when you're actually learning or training. It could be something like size of the neural network. I'd say I need 40 layer network or 50 layer network. Or it could be model algorithm parameters, something like learning rate, right? So those can be changed. So model parameters and algorithm parameters are the two different kinds that you have for hyperparameter tuning. Then finally the prediction or the output. So it could be classification also. In this particular slide we have just shown the prediction. So that's the final output that you would be getting for machine learning. So these are the different kinds that we have for the machine learning. It could be supervised, unsupervised, and there's one more thing that is reinforcement. RNN, you would have heard that reinforcement is something like, you feed in the whatever the output that you're getting, so you reinforce, or you something like trying to memorize, something like trying to correct it. So it does find a lot of application these days in many of the areas, that is reinforcement learning. So rather we would just concentrate on supervised and unsupervised. So when you come to supervised, I have already told for the label data, you have the regression, you have decision tree, random forest, and classification. These are the four prominent methods that people make use of. So regression, I've already told. Here you're trying to come up with a relationship between the variables, and you're trying to find which one is the best fit, which model, which line, which equation is the best fit for the data that you have given. Okay, so it can be used for the prediction, basically regression, but it is also used for the classification, but it is basically used for the prediction. And there could be two kinds, that is the linear and polynomial. Linear is usually for the continuous data. Polynomial, let's say the data is way too complex and you cannot come up with a linear relationship between the variables. Then you would be going for the polynomial regression. Then we have the decision tree. You try to come up with different kinds of trees to decide on something. Enhancement to decision tree is your random forest. Basically, there are many decision trees. It's an ensemble of decision trees. That is something like an ensemble learning that happens in your random forest. So several decision trees you would have taken together so that the accuracy is better, whether the prediction or the classification output would be better. So that is where in many applications I've seen people making use of random forest. Then we have classification, which can be either done through k nearest neighbors, the trees, or the logistic regression. Naive Bayes, it's based on the probabilistic model, and SVM is your support vector machine. Support vector machine is also used for both linearly separable, linearly non-separable kinds of data, where we try to come up with a hyperplane. We try to come up with a hyperplane which segregates two different kinds of the data. That is your support vector machine, that is very commonly used for classification, and especially for the application healthcare, especially the brain images that I was working on. Throughout, the one that I used was support vector machine for its simplicity and the accurate results that it were giving. Because if at all I try to go towards a deep learning or something, it is very computationally complex, and it takes more time, and I would need very advanced systems to do it. So rather, SVM was much more sufficient to give the performance that I was looking for. So regression, decision tree, random forest, and classification. Under classification, k nearest neighbors, decision trees, logistic regression is mentioned because that can also be doing the classification. Naive Bayes is something like, it does a probabilistic classifiers based on the Bayes theorem, and support vector machines. So that's for supervised. When we talk about unsupervised, I told you we don't have the labeled data set. So we have certain clusters that we would be working on. So we have singular value decomposition, SVD, PCA, that is your principal component analysis, and k-means clustering. So these are the three very predominantly used one. So basically your singular value decomposition, it's another way of factorizing the matrix. See, people, one thing about clustering, unsupervised is I don't have a labeled data set. I could be having huge data set which I need to manage. It could be a raw data set. I don't know how it is, what it is. To come up with certain patterns, to analyze the complete data set, I would be going for this clustering kind of algorithms where SVD, PCA are much, much helpful. So singular value decomposition helps me with, factorizing the matrix and coming up with singular vectors. So we use this for compression, denoising, and many other applications. The next thing is your principal component analysis, which is used for data analysis. And also people use this for, let's say I give a huge data set again, and I cannot be using so much because it takes more computational time and that might not be very efficient for my machine learning algorithm. Then I would be doing principal component analysis to analyze, reduce the dimensionality of the data. I repeat, PCA, principal analysis, is predominantly used for the reducing the dimensionality of the data. So I feed that further into the next algorithm. It could be your random forest or say SVM, where further I can use it. So it's a reduced data set, and I can, usually people do a combination of these. People do PCA plus SVM and PCA plus decision tree. So the combination k-means plus, I use k-means plus SVM. So because I had a huge database, I wanted to reduce that. So k-means clustering is something where it is something like a vector quantization, where we group it and we identify the basic vectors, and those vectors, will be able to help you with, just I take those important vector representations and take it to my classification. Those would be my features. So that is where you have this SVD, PCA, and k-means. The next thing would be your association analysis. We try to analyze the association. There is two techniques, a priori and FP growth. FP is like frequent pattern generation. So this is basically to come up with a relationship between the data. A priori does work, but FP has much more advantages. It was considered to be much better. And we have hidden Markov model. Hidden Markov model, I don't know how many of you heard about it. It was predominantly used for the speech recognition systems, and major speech recognition research was with hidden Markov model. So that's basically the different areas, different machine learning algorithms that's available. This is just small set that I'm showing, which you people can be using for your research. So the next thing would be the artificial neural networks. As I mentioned, that is, if at all I have an artificial neural network with more than 3 layers, then I call it as a deep network or deep learning. deep neural network, DNN, any of them. So dense neural network. There are different terminologies people make use of, but always the basic thing is any artificial neural network more than 3 layers becomes your deep learning. So here, if at all you don't need so much of computations, you can go for a smaller networks itself. In artificial neural networks or the deep learning, all that we are doing is trying to mimic the human brain itself, trying to come up with a simplified system. And I would rather skip this because I don't think I would be going for the depth of it with a given time. It just basically, how the artificial neuron takes all the inputs, it calculates a weighted sum with certain activation function. It could be ReLU or sigmoid function. Depending on that, it would be trying to give an output. So why deep learning? Why artificial neural network? It's been found that as more and more data is given, the performance wise, the deep learning performs much better than the other learning algorithms. It's definitely much better in every way. It's only that it takes high computational complex systems and high computations. So that's the only disadvantage with the deep learning. But if it is something which people can afford and the time consuming also, if all these things can be done, the deep learning is best for almost all the applications. Coming to the applications, so I've already mentioned these, but that is whenever I mentioned about the applications, it could be robotic assisted surgery, facial recognition, predictive analysis, administrative workflow, how exactly the administration happens, healthcare and nursing, cybersecurity, natural language processing, fraud detection. That is another thing for the security, cybersecurity and management and fraud detection I didn't mention earlier. And we do have the connected systems. So we'll just take few of them here as specific. So one thing is your AI in healthcare. As I mentioned, healthcare is one area where AI is finding its lot of application. So what are the things that we want the AI can do? What are the things that AI can do? One thing is it just to check if at all the well-being of the individual, whether an individual is keeping well. That is the most basic thing. Just to, people, we wear something like certain watch, we wear a watch where, it is just monitoring our pulse rate. It could be monitoring our, how fast we are walking, how much we have walked, how much exercise we could do. So there's actually some intelligence in those smart watches that people wear, right? So that is keeping well. Early detection, as I mentioned, the early detection of, say, Alzheimer's disease. That was one project that I had worked on. Using the brain images, we were looking at, I was trying to predict whether an individual would be getting an Alzheimer's or not after a certain age, right? So early, it could be like, a person could be getting a cancer. So those kind of early detection or the prediction is one thing that can happen in healthcare. Diagnosis of a certain ailment, decision making. So let's say I have taking up a robotic surgery. If it is not a remote surgery and the robot, it is so sophisticated, it can do a certain thing. It might have to take a decision after this particular step, what I need to do. So decision making becomes necessary in healthcare as well. Treatment. So if at all somebody does not have an access to the doctor or anything, looking at whatever the symptoms a person have, he can suggest certain treatment. Though right now we are not in a position where we can totally out and out trust these particular system, but let's say even in the remote places, especially during the COVID, the healthcare and the AI found so much of applications wherein people looking at answering few questions and few things, we were able to key in whatever with what we could key in. We were trying to predict whether a person has COVID-19 or not, right? And also try to tell them, isolate yourself, do this, do that, take these things. So basic treatment can also be done with the AI. End of life care, the taking care of it. Lot of research and training, yes, that is always there in every field. That is AI in healthcare. And one more thing would be the AI chatbots that we have. So here earlier, what people used to do, they used to just go Google, just to, the first step that you can see in the particular slide, the search engine. They used to just give, okay, I have these symptoms, what happens? Even now we do that. But, that search engine was people were using. They used to go to the social media platforms and try to say, whoever is online try to tell these are the things that I have, what I can do. And or they used to use the smartphones, apps, messenger apps. Now with the artificial intelligence, self-learning machines have become so much smarter the more they are used. And what we have right now are the health bots. Health bots is something where, let's say, you are in a remote village or something, don't have immediate access. Even in your mobile phone, at least people are connected through that. You will be able to key in certain, what are the symptoms you have, and that bot itself will be able to help you, aid you, make an intelligent decision. And it is not that it finds application only in healthcare, it can be done for other things also, but this is something more important and relevant. So health bots is one thing. Human resource, this is basically for the MBA people, recruiting, engagement, learning, and the complete employment cycle. So all these things, if at all you people are trying to look into the LinkedIn jobs or something, what's relevant to you, it's shortlisted and given to you, right? So that's happening because of the AI there. Onboarding, let's say you join a new job, onboarding process is made much more simpler with AI. That is engagement, that is you are trying to communicate, you have some PF issues or something, through the HR chatbot or surveys, you can always have a continuous engagement. Learning, skill development and training can also happen with AI. So the banking and fraud detection, maybe with the limited time that I have, I might not be able to go through this in detail, rather go to my projects that I've worked on. So basically here, whenever you key in or you put your credit card or the debit card or anything, so there is a lot of AI that happens to authenticate, to see if at all your what is your bank balance you have, what transactions you are allowed to do, what can be done, what cannot be done. Everything happens with AI in banking for fraud detection. So these were the trends in 2020. One thing where all it found a lot of application. Something more relevant, of course, I did mention healthcare, chatbots and automated business process, that is the HR, recruitment, cyber security, AI mediated media and entertainment. Let's say what is needed, what you like the most is something which would be suggested if at all let's say you're watching a Netflix or Amazon Prime. So that is AI mediated media and entertainment. What you like is what is offered to you. And one thing more relevant is the robot process automation, and aerospace and flight operation is actually controlled by AI. There's a lot of applications that you find in aerospace as well as your robotics. So the last part of it, I would just touch upon with several projects that I've done. I just chose 3 projects which are also relevant for mechanical engineers, where I could see AI and robotics went together. So these are the 3 projects which I'm currently working on. These are not the old ones. These are something which I'm currently working on. This particular project where remote patient engagement platform from rehab specialists, that is a physiotherapist. This particular project I've been working with one company by name Sensible. So basically with that company, I'm just, we are working together. We are also writing for the funding together. So basically, we work for the geriatric population. The way you have pediatrics, that is the kids, geriatrics is for the old age people. So basically, the physiotherapy is one major need for people who had seizures or who had certain difficulties or a high level of arthritis and things like that. Since people cannot go personally and always train them, or people, they are in remote places, so we are trying to come up with certain system. Let me just show you the system. We are trying to come up with a system which would help people be engaged and work with being at home. They will be able to do the physiotherapy. Physiotherapy is something which is extremely important for the post operative or care, and especially for the geriatric population. Let's say there are people, old parents who don't have anybody to take them, or physiotherapists cannot reach them. Then what we are trying to come up with is what you can see on the left side. The person is holding is definitely a mechanical system, where we have sensors, accelerometers, and those things which takes how exactly you're performing, how many movements you made, how's your movement, how's the angle, what angles you did, and all the physiotherapy exercises that those were suggested to them whether it did properly or not. That's an equipment where they would be doing. That would be tracked by an app, or if at all they have an access to the computer where it would be tracked. If at all it's just an app they're using, we also give suggestions. Okay, you need to raise your hand above, you need to bring down your hand. Either can connect directly to a physiotherapist, or in the let's say the physiotherapist is not able to cater to them. We are trying to create an intelligent system using AI, where the physiotherapist, whatever the suggestions the physiotherapist would have given. So depending, let's say the hand had to be in the 45-degree, but the person is doing it in say 30-degree or something. So the physiotherapist will be able to give suggestion. That is the AI physiotherapist, the virtual physiotherapist will be able to give a suggestion. Make your hand, bend your hand in certain degree, certain way. So that is where we are trying to make the system. We are almost done with the software part. We are working on the hardware part, where we are taking inputs from the mechanical engineers, where we are trying to create this particular system where, it aids, helps the geriatric population and the physiotherapist. So it's a distance, will be able to do a certain physiotherapy operations. So that's one application that I'm currently working on. Another thing that in the beginning I mentioned, one thing is with the NIMANS, where the gross motor developmental issues the kid would have. It is a certain duration the kid is supposed to sit, stand, crawl, and walk. So, but if at all it misses out on that, you can see the statistics on the slide. Around 5,000 to 6,000 children per year visit the NIMANS. So basically, if it all misses out on that, we want to come up with the certain devices, so that we will be, see here, physiotherapist is holding a cloth and trying to make the kid move. But if we want to come up with a device, it is something with robotics and intelligence where it will be able to aid. This is that was a bit more complex, but this is much more simpler, where we are trying to aid. See, the person you can see on the screen is somebody who is trying to assist the kid to stand up and walk. So that would be able to come up with, you can, the rightmost corner, you can see the depiction of the chair that we're trying to develop. So where it will be able to help the kid. So we try to embed this particular device to the stroller or parameter, whatever the pram that the parents use, so that it will be able to help the kid to stand up and walk. So that kind of an assistive technology. So this we are actually trying to collaborate with the mechanical engineers, and the intelligence part would be here. See, this is otherwise it would be just a robotic system. Intelligence part would be where it will be able to track how's the progression, how much it is doing. It will be able to assist it depending on that. So that's where the technology is coming in. And one more project that I worked just a year back was about autonomous vehicle, wherein, I know the autonomous vehicle is one the thing. What it has to do, it needs to sense the array of sensors, perceive, identify, and classify what it saw, and act on the insights through automatic control of the vehicle. So these are the methodology. I might not be able to explain this in detail. Perception, that is computer vision, and understanding, localization, where I am, what am I doing, how, and path planning, what route I need to take, and the final would be the control. So the first part was the image segmentation that we did. These are the results what we have got. So here we try to identify different cars and different objects that's there in front of us. And after that, this was a device that we developed with a Raspberry Pi, and this particular, whatever the robotic car assembly, the complete setup, I just got it from US, so that, the students will be able to implement the project there. So this Raspberry Pi, everything we procured here, and that whatever the wheels and the setup that you could see, it's actually available online, but you need to source it through the US itself. So through from US, I just got this. We did a setup, and we did two kinds of testing, that is training on the straight path or training on the circular path. Currently, I don't have a video to show you, and also I'm running out of time. Here we were able to make this particular vehicle. It's a very small vehicle. You can see two things we implemented. One is it is used to recognize the images and take a decision to go straight, take left, and also vehicle to vehicle communication. On the left side, you can see we have kept an obstacle. So it was able to check on that and move or avoid the obstacles also. And vehicle to vehicle communication, we are not showing in this particular image that I have. So if at all there was one more vehicle, it used to communicate to make further decision whether that person is going to overtake come forward or go behind. Those decisions are also were taken. This was a device that we had developed. So that's the image. So the last thing, since it's already 12, it's almost hitting on 1. So AI is probably the most important thing that humanity has ever worked on. So I think we should be part of the revolution, irrespective of which background, which engineering field we are. We need to collaborate to come up with the most intelligent system. See, it cannot be just a computer science. Just a brain cannot do everything. We need hands, legs, we need a mouth, we need everything put together for us to be the complete human beings and to go further. So that is where the whole thing becomes more relevant. So thank you, people. I did go a bit fast towards the end, owing to so that I stick to the time and I don't come behind between you and your lunch. Sorry about going a bit fast towards the end. I wish I had explained my projects much more, taken it early. Sorry about that. Maybe I needed more than 2 hours. Hopefully we'll be able to connect and talk again sometime about the projects. Thank you so much for the opportunity to the Department of Mechanical Engineering, the NMIT management, and the organizers of the FTP. Thank you so much. Any questions, anything, you can always write to me for the mail ID. You can take my contact details also from the department. You can always reach out to me. I'll be glad to collaborate and work. Thank you so much. Thank you, sir. Over to you. Sir, you're muted. Sir, you're muted.
Yes, madam. On behalf of Department of Mechanical Engineering and all the participants over here, we thank you very much, madam, for your insightful presentation and for emphasizing us with a lot of examples. Your talk was predominantly and particularly appropriate at this time when we are considering new initiatives for expanding into multidisciplinary areas. So at this point of time, I would like to hear from our participants if they have any questions over the session. Participants, you can unmute yourself and you can ask if you have any questions.
Hello.
Yes. Yes, you can go ahead.
Good afternoon, everyone. Good afternoon, madam. I am Jagannath Gupta from Markov College of Engineering. Hope I am audible.
Yes, sir. You are audible, sir.
Thank you. First of all, let me thank madam for the exhaustive, educative, and informative session on the topic. And my question is, if I want to implement a simple lab for the students of MTech, machine design students, what basic facilities have to have in this field?
Thank you for the question, sir. So basically, sir, one thing is you have a good computing system, and let's say now you can do it with a Python and also Google Colab and many platforms. So with a good computing system and a Python itself, they can start working on it. Since we are definitely, even I come from an electronics background, you're from mechanical, we want to take it to the hardware. How I worked was I was just trying to work with low cost. So we used to take up basic Raspberry Pi. If at all I want to implement deep learning, Raspberry Pi might not be able to take. So what I did for 8K, I bought a neural computing stick from Intel. Online it is available, sir. The most advanced ones are there. So with the Raspberry Pi, with a neural computing stick, I could actually implement that autonomous car. So it will be, though you can start with those simple gadgets. Later you can start enhancing your lab with NVIDIA GPU. Let's say the gaming laptops are the best, sir. If at all you're trying to learn, run the artificial neural network or the deep learning algorithms, you can go for high-end gaming laptops with GPUs. And later you can also venture into the NVIDIA processors. That would be the hardware part, sir. For simple student projects, with you can start basically with Raspberry Pi, neural computing stick, and a basic good computer itself, sir.
Okay, thank you very much, madam. One more question can I have?
Yes, sir.
Madam, if you want, say, for example, if you want to implement this deep data science or deep learning, for the case of, say, for example, aircraft wing, which is subjected to fatigue loads, lots of different loads, which leads to fatigue. So there is a chance that because of fatigue, there is a chance of initiating of the cracks on the surfaces or inside.
Correct, sir.
How exactly can we implemented this particular technology to avoid or to predict or foresee the effect of those loads, madam, on the effect?
Sir, let me tell you how the complete data science or machine learning works is, it takes the data, let's say in past 20 years, it will take the data wherever the wing had that crack or whatever you said. Let's say this Airbus so-and-so had a crack, and why it had a crack, people would have already diagnosed it. It would take all the data and will train, let's say, the artificial neural network or any of the machine learning algorithms, sir. So later you give a data, okay, this is my Airbus, these are the characteristics, it is running in this speed, it is running in this environment. You feed that data, then it will be able to predict, okay, so this particular, with whatever knowledge but it had, it will be able to predict, okay, this airline has a, let's say, 70% probability after 10 years of its flight, it might get a crack. So that is how it actually predicts, sir. It's only the data which can train. The previous data, sir.
Thank you. Thank you very much.
Thank you, sir. Thank you for the question, sir.
Hello, madam.
Yes, sir.
In connection to the same problem, I would like to ask you that usually when we train the model with huge data set, we are able to accurately model the fatigue life of machine components within the data set by interpolation. But what happens actually is when we go outside for extrapolation, we tend to get a bit of conservative results. Accuracy may slightly go down. So in such cases, what to do, madam? What is the solution in such cases?
The more the data you have, better the accuracy of your prediction, sir. It's more the data. That's how accurate the systems will become.
Yes, madam.
And also, train the model with 10 examples, the prediction will be less. You train it with 1,000 examples, the prediction becomes better. That is one thing I can think of, sir. Here it is more of a prediction algorithm. Regression and any of these things can help you with this. So just to predict on the predecessing, sir, how, if at all this situation occurred for this reasons, if at all this also goes through this reason, this might happen. But you have to give more parameters there. Considering I'm not, I don't know much about airspace, but weather, climate, winds,
yes, madam.
So many things.
Definitely.
So because those parameters also you need to give more and more features, sir, more and more parameters for training, it becomes more accurate.
So since it influences many factors, we need to accurately, yes, sir, we have to give that input. Yes. Okay, madam. And another thing is how to decide upon the hidden layers, madam, like hidden neurons.
Yes, sir. So basically, sir, your hidden layers could be 1 layer, 2 layer, 4 layer, 10 layer, 200 layers. So more and more hidden layers, more and more layers, the algorithm becomes more complex. It is more time consuming. Sir, it basically how the machine learning people do is it is only through experience. So by experience, I would have executed, let's say 10 projects. Then I'll be easily able to say this is how much I need. It's majorly by trial and error, and more you work on it, sir, in that particular area, more expert you are. And one thing, sir, as far as since you asked this question, there are 2 ways of learning. One is you yourself can create a neural network. Let's deciding I'll have 3 layers, 1 hidden layer, so 50 neurons. You would decide, you create, you feed in the data, train it. Or you can do something called transfer learning, sir. There's already ready neural networks, very powerful neural networks from Google, Amazon and all. So let's say Inception V3 is one most powerful neural network you have. It can be used through Google, MATLAB or Python. What you do, the whole application, irrespective of hidden layers or anything, use that directly, sir. It's very easy. So you directly use it. So with that already trained neural network that is given by, let's say, Google, you use it. It's a very powerful neural network. You can use it. You need not even decide on number of hidden layers then. It's a trained model. It can do for anything. Transfer learning is what you can do, sir.
Thank you so much, ma'am.
Thank you.
And I request other participants, if they have any question, they can ask.
So good afternoon. Myself Chaitra from BNMIT. Ma'am, good afternoon, ma'am. May I know, is there any specific prerequisite for learning deep learning other than machine learning basics?
Not really, ma'am. Not really. You can directly start learning artificial neural network or the deep learning course. And as and when you can learn Python would be little useful, ma'am. But also the MATLAB also is much more easier. So you can start with a small course which is already available in the net or something. Start executing and learning, ma'am. There are a lot of very good online courses, ma'am. Deeplearning.ai is a good platform, and also Coursera is very good, ma'am. Since the Google, whoever was working, Andrew Ng himself has created Coursera, and he teaches the introduction to AI and deep learning courses, ma'am. You can take up those courses and start working. There's absolutely no prerequisite.
Okay. Thank you, ma'am.
Thank you, ma'am.
Okay. Any other participants? If you wish to ask any questions, you can. Okay. Okay. Thank you, dear participants. A recorded version of this session will be available for you for your reference, which you can always look into later. So at the end, we hope, madam, you will consent to speak to us again, since we are now blending AI in our curriculum. So we need your expertise in the subject to us as well as for our students. Perhaps next time we would like to have your consent at this time, so that you will always share your experience on AML.
Hopefully I'll have more time to share the project, sir. Sorry about time. I had to hurry up a bit towards the end. I had to go a bit
Thank you so much, ma'am. Many thanks from all of us. Thank you, ma'am. Have a nice day.
Thank you so much. Thanks for the opportunity. Thanks out to all the participants for the patient listening. Thank you.
Thank you, dear participants, for participating for this session. And we look forward for your active participation tomorrow at 9:30 a.m. Thank you all.